Now, this varies from if we had done even the same thing, but we had a greater than inequality, absolute value inequality. Okay, so if we're dealing with an absolute value inequality that has a greater than, okay, opening toward the absolute value expression. So let's take a look at that case. And the equal to doesn't matter. The equal to just determines whether those critical points are included or excluded in your solutions. Okay, but if you have a greater than, first you're still going to look to isolate absolute value expression. In this case, it's already done. Okay, but your next step here is instead of sandwiching together, you're going to split into two inequalities. Okay, and the way that you're going to split is just like with an equation, you're going to start with exactly what's inside your absolute value expressions in both sides. On the right side, just copy down what was given, so greater than or equal to 10. On the left side, you're going to compare it to the opposite of 10. And in order to get the opposite of 10, what did you have to do to this number? Multiply by. And when you're dealing with inequalities, when you multiply or divide by -1, what do you do with the symbol? We switch it. Okay, so when you split this, you have to switch the symbols for the left side or for the opposite side. Okay, once you do that, okay, so now you've turned this into an OR absolute value, or an OR inequality, instead of an AND. So now you're going to solve the resulting OR compound inequality. Okay, so here we'll just solve each one independently. So what do you expect your answer in interval notation is going to contain if you know you've split it here? It will in brackets because of the equal to, that is correct.
A U.
The U. So now it's split, so you're going to have that U in your solution set. So be, again, anticipating that is helpful. And then just solve each of these independently. So again, if we subtract a 2 from both sides, and then in each case, we can multiply by the reciprocal, 3/2, to get our x completely alone. So 2 goes into -12 6 times. So -6 times a 3 gives you x is less than or equal to -18. Here, oops, if we multiply by the reciprocal, the 3 and the 2's cancel. 2 goes into 8 4. 4 times 3 gives you 12. So here is our inequality notation. If we put this into interval form, what you have is, in this set, x is less than -18, so -infinity to -18. Can never include infinity. Do we include -18? Yeah, so here's the bracket. And then here x is greater than 12, so we have 12 to infinity. Again, you cannot include infinity, but the 12 you do. So this would be the interval notation for this.